Every December, millions of households around the world set up a tree in the center of their living room, decorated with twinkling lights, shimmering baubles, and ribbons. It's one of the most universal symbols of Christmas. But have you ever taken the time to wonder how these trees are made, especially when they are artificial? Every year, more than 50 million artificial Christmas trees are produced to meet global demand. They don't grow in forests and are not cut down with axes. They come from a meticulous industrial process where huge factories in Asia transform plastic materials into almost perfect replicas. But how do they manage to give them such a natural look? What technology lies behind such a common object? And how can up to 10,000 trees be produced per day? What looks like a simple party decoration is actually the result of decades of technical evolution, millimetric precision, and impressive industrial design. Today, we are going to discover how an artificial Christmas tree is made. From its origins to its modern assembly on optimized production lines, get ready to see one of the most iconic holiday objects as you've never imagined it. Even though artificial trees seem completely modern today, their history actually dates back to the 19th century. In a Germany already concerned about deforestation, the idea of a reusable tree began to emerge. The first solution was as ingenious as it was strange. Feathers dyed to look like glass, fixed on wooden structures. The result could be elegant, but these trees remained fragile, costly, and extremely difficult to produce in large quantities. At the beginning of the 20th century, manufacturers in the United States replaced the feathers with metal strips and synthetic fibers. The fir trees became stronger, more durable, and more accessible. But one essential element was still missing: realism. The fibers were too shiny, too stiff, and did not replicate the texture of a real conifer. Everything changed with the arrival of PVC, polyvinyl chloride, in the mid-20th century. This plastic was not only economical and durable. Above all, it made possible the creation of flexible needles, varied colors, and the reproduction of the density of foliage. This is the modern artificial fir tree, the one instantly recognizable today. Over the decades, production has largely shifted to Asia, where major industrial groups have developed techniques capable of mimicking the finest details. More realistic veins, branches oriented at natural angles, trunks textured like real bark. What began as a handcrafted response to an ecological problem has turned into a global industry, powering homes, shopping centers, and public squares in many countries. A modern artificial Christmas tree always starts with a combination of plastic and pigments. In the most advanced production sites, everything begins in the extrusion area where two materials dominate the process: PVC and low-density polyethylene, often called LDP. These plastics arrive in pellet form. They are heated and melted at temperatures up to 180 degrees Celsius until becoming a malleable material. To this mixture, very specific green pigments are added, sometimes up to 12 different shades depending on the ranges, to reproduce the natural diversity of colors of a real fir tree. The melted material is then pushed through metal dies that transform it into ultra-thin sheets, sometimes only 0.1 millimeters thick. But these sheets are not simple flat strips. They pass between textured rollers that imprint patterns mimicking the veins of natural needles, with precision reaching down to 0.01 millimeters on the finest details. A factory can operate up to 20 extrusion lines in parallel, producing more than 2,000 square meters of material per hour. Each sheet thus forms the base of artificial foliage, so convincing it becomes difficult to distinguish from a real conifer. Once these textured sheets are ready, one of the most delicate steps begins: cutting the needles. Here, high-speed cutting machines carefully cut each sheet with millimetric precision to replicate the exact shape of needles on a natural fir tree. Each machine uses hardened steel molds capable of making up to 120 cuts per minute while maintaining a consistent sharpness. These molds cannot be used indefinitely. They are changed regularly, sometimes every 8 hours, then checked with very fine inspections to ensure that the level of detail does not degrade with wear. Precision is essential, as a variation of only 0.5 millimeters can alter the overall appearance of the tree, especially when hundreds of branches are assembled together. Factories often use about 15 different needle designs. Some are shorter, others longer, more curved or thicker, to replicate the actual diversity of conifer species. The machines can produce more than 50,000 needles per hour, then automatically sort them using industrial vision systems that analyze each piece in real time. This system is not only meant to speed things up. It also ensures that each shape corresponds to the correct type of branch, guaranteeing a harmonious, consistent, and botanically believable final result. Once the needles are ready, the structure that will shape them must be made, the branches. And contrary to what many imagine, these branches are not produced randomly. Each branch is designed according to the position it will occupy on the tree: base, middle, or top. We use galvanized steel wire, cut to the exact length. A machine first cuts the wire with very fine precision, then bends it at specific angles to create the basic shape of the branch. Next comes the hot dip galvanizing treatment, an essential protection against corrosion, especially if the tree is stored for several years, sometimes in humid environments. Once galvanized, the wire receives a coat of green paint applied through an electrostatic process, ensuring uniform coverage even in hard-to-reach areas. This shade is chosen to blend perfectly with the tones of the needles. A factory can process up to 2,000 kilograms of wires per day, which corresponds to the production of tens of thousands of branch structures. Each branch is then mechanically tested. It must be able to support a minimum weight, often around 500 grams, without deforming, so that the tree can hold decorations without losing its shape. The trunk itself is the tree's backbone. Its manufacture must combine strength, stability, and the most natural appearance possible. It is generally made from steel tubes about 2 millimeters thick. These tubes are treated against corrosion, then coated with a textured plastic. And this texture is not random. It is often obtained from molds of real tree trunks, allowing the reproduction of reliefs, cracks, and irregularities that create the illusion of authentic bark. The coating is fixed by heat and pressure, resulting in a very realistic finish. The trunks are then precisely cut, sometimes with a laser, and pierced to accommodate the branches. These holes must adhere to extremely strict tolerances, sometimes as tight as 0.1 millimeters, so that everything fits snugly and the final tree remains perfectly aligned. The base of the tree is often produced by injection molding, using plastic reinforced with fiberglass. This material combines lightness and strength, and the base is designed to support several times the total weight of the tree, while withstanding the stresses of transportation and installation. Factories can produce thousands of trunks per day, with sizes ranging from 1.20 m to 3 m, depending on the models and target markets. When the needles, branches, trunk, and base are ready, the most anticipated step arrives: assembly. It is a blend of mechanical precision and human expertise. On many assembly lines, operators manually insert the branches into the trunk following a computer-guided assembly pattern. This plan ensures symmetrical distribution, a perfect conical shape, and uniform density. The branches are not all oriented in the same way. The angles vary greatly. Branches can be positioned at 120 degrees near the base for a wide and dense look, and at 45 degrees near the top to mimic natural growth patterns. Depending on the size and range, a Christmas tree may require between 200 and 1,000 branches. Once assembled, the tree goes through a compression zone. Hydraulic presses reduce its volume by up to 75% to simplify transportation. Next, it is packaged in reinforced cartons, often triple-walled, capable of supporting heavy loads without crushing. The packaging includes compartments to protect the foliage, multilingual instructions, and sometimes QR codes linking to assembly videos. Automated lines can package several hundred units per hour, ensuring traceability, safety, and uniformity. The artificial Christmas tree we know today is therefore the result of more than a century of innovation. From dyed feathers in Germany to reinforced structures produced on a large scale. This holiday symbol has evolved alongside global technology and culture. The current industry not only makes trees that look real, but also incorporates sustainability improvements. Some factories have begun using recycled plastics, and others reduce their energy consumption through more efficient processes. Models now come in all sizes, from small desk trees to giant trees over 12 meters tall installed in public squares. Some models even include integrated LED lights, pre-shaped branches, or artificial snow effects. And even though manufacturing is industrial, each tree remains a complex assembly where engineering, design, and detail combine to create one of the most universal objects of the Christmas season. What looks like a simple decoration sometimes hides a true industrial feat, made to bring a festive atmosphere to millions of homes around the world. And now, in your opinion, Is an artificial Christmas tree reused for several years more ethical and ecological than a natural tree cut down and ultimately thrown away after each Christmas? The debate is open. React in the comments. If you like this documentary, don't forget to like, subscribe, and activate the bell so you don't miss any of our content.